Hello students, good evening. So today we are in the sixth session of the electrostatics force and field part. Okay. So before we begin the session, right? Already session 5 I'll just give a quick idea of what we were looking at the session 5. Okay. So session 5 we started the idea of electric field. So in the we have got the idea of this electric field. It came from the field theory and solute. Like all these fundamental forces are the basic forces, right? Gravitation force or the magnetic force or the electrostatic force. Okay. So all these forces they operate by the field theory. Field theory, if you have two charged particles, right, they are not going to directly interact. So say for example charge 1 then charge 1 is going to develop electric field around it. Adoda surroundings it will develop what? Electric field. Okay va? Now when you bring charge 2 into a particular place, okay, whatever the electric field and whatever the electric field that is there, right, this electric field is going to interact with the charge 2. So who is generating this electric field? Charge 1. So charge 1 develop an electric field kuda the charge 2 will interact. Okay, so if you have any charge at a particular location and electric field at the location is E bar and electric field is a vector quantity. So it's a vector quantity. Then the force acting on the charged particle at that location is given by what? Q times the E bar. Okay, already we have seen two conclusions. Positive charges, right, they experience force in the E bar direction, means positive charge and it will start experiencing a force in the direction of electric field. Means if it is at rest, means the positive charge will start moving in the direction of the electric field. Okay va? If you have negative charge, means the force will be in opposite direction to the electric field. So then I'll look at this relation. F is equal to Q into E bar, right? So Q positive means what? F bar and E bar will be in the same direction. Illana, if Q is negative means what? F bar and E bar will be in the opposite direction. Okay, so this is last class. Now in today's session, right, we will start learning more about this electric field. Okay, so we'll start more with the idea of this electric field. So how do we define this electric field? So the concept of electric field is known to us from the field theory. Now how are we going to define this electric field? We will define this electric field by using that same concept. Say for example, in that we want to know what is the electric field. So what we are going to do, we will look at a charge. We will bring a charge to that particular location. Okay va? If we can find out what is the force acting on the charge, if we can find out what is the force acting on the charge, okay, there are different methods. We can find out what is the force acting on a charge by using various techniques. Okay, if you are able to find out the force acting on the charge, then what is the field theory relation or formula? Force acting on the charge is equal to what? Q times electric field at this location. So in the at this particular location, let us say electric field E and H find out. So what is the field theory relation? Force acting on a charged particle Q at a location is equal to what? The particular charge times electric field at the location. We are looking for E, right? On the Q left side. So Q will go to the denominator. Okay va? So this is the expression. So you know how we are going to define this electric field. Electric field is defined as force acting per unit charge. Eppadi define pandrathu? Force acting per unit charge. Adana we are, so Q charge it is experiencing a force F. We are simply dividing the F by the Q value. So how do you define the electric field? Force acting per unit charge at a given location. So if you want to find electric field at a given location, means how we are going to find it? It is nothing but the force acting per unit charge. This is how we will define the electric field. Okay va? Now when we want to really measure it, measure பண்ணும்போது என்ன தெரியுமா, this is the way we defined it. But when we are really measuring the electric field at a location, like the way scientists do the experiment, when they do the experiment, they are going to operate in a particular way. அது எப்படி தெரியுமா பாருங்க, if you are using a charge, so you are using a charge, right? So you want to find electric field at a location வெச்சுக்கோங்க. So now what you are doing, you are bringing a charge to the location. Okay, now the relation from the field theory is what? Force acting on the particular charged particle is equal to what? Charge times the electric field at the location. So in that, if the electric field is E, what is the force acting on the charged particle? Force will be equal to Q into E. Idhil enna theriyuma, if the charge that you are bringing is a positive charge, appo you will have a simple relation in terms of the directions. Paranga, if the Q is positive, already nama sollirukom, the force acting on the charge will be in the same direction as the electric field. Means you are bringing a charge Q to the location, right? So if you consider the charge to be a positive charge, then it will help us in easily tell the direction of that electric field. Whatever the direction and the charge is experiencing a force, electric field also will be in the same direction. Adanala whenever you are using this experiment to find out the electric field, right, we will generally prefer what? Positive charge. Enna positive charge enna vechukonga, then straight away you can tell what is the direction of the electric field. So whatever the direction in which positive charge is experiencing a force, the electric field will be in the same direction. Adillam ingonnu idirukka, when you are bringing a charge to the location, what happens is, if this charge is a large value of charge enchukonga, then what happens is, see how this electric field is coming to this particular place. How this electric field is existing in the place? Because of நம்ம சொன்ன மாதிரி, what is it? Because of the surrounding charges தானா. அந்த இடத்துல whatever is the surrounding charge present, they are generating this electric field. Okay, because electric field is generated by the charge itself. Surrounding charges are developing the electric field. So if the charge you are bringing to this location is a large value, அப்ப என்ன ஆகும் தெரியுமா, the surrounding charge oda arrangement will get disturbed. Edanaala, because if you are bringing a very large amount of charge, this large charge is going to repel everything or attract everything, right? So you are bringing a large positive charge means all the surrounding positive charge will be repelled. அதே மாதிரி all the surrounding negative charge will be attracted. அதனால என்ன ஆகும், the surrounding charge oda configuration will get disturbed. So to avoid it, experimentally நம்ம இந்த electric field measure பண்ணும்போது what you are going to choose is, you are not going to choose a large value of this test charge. So in the you are bringing a charge to the location, right, to find out the electric field. Adukku enna theriyuma, we will call it as what? Test charge nu solluvom. So test charge will be usually small and positive. So this is an important theoretical question, theriyuma. So why do we choose test charge to be small and positive? Edanaala, small charge means this charge you are bringing to location, right, that is not going to create disturbance in the surrounding charge arrangement. Already in the surroundings there is a charge that is present, adanala da in the electric field varudhu. So if you are bringing a charge to that particular location means you should not disturb that surrounding charge arrangement. So if the large charge you are bringing means, what is going to happen, and the surrounding irukra ella charge configuration will be disturbed. Adu aagakodadu. If the surrounding charge arrangement is disturbed means whatever the previous electric field that is there at a location, right, that is going to change. Then it is not of use for us, right? So when you are wanting to find the electric field, we should not be doing something that will disturb the existing arrangement. Adu nama disturb pannakodadu. So adanala we will choose what? A small positive test charge. Okay va? So this is the approach in which we are going to find the electric field at the location. So we are going to bring a small positive test charge to the location, and when we look at the relation, what is the relation? Force acting on that test charge is equal to what? Q into E. Test charge enidhukku nama solum theriyuma, because this is used for the testing of the electric field. Okay, so this Q is what you are calling as the test charge. Inga parunga, force divided by charge is equal to what? E. Now in some textbooks, if you look at it, right, they will give this kind of a formula. Paranga. So they will say limit Q approaching 0. So இது கொஞ்சம் நம்ம சொல்லலாம் tending to 0 ன்னு சொல்லலாம். Limit Q tending to 0 F bar by Q. So like that they will define the electric field as a location. Because remember what we are saying, the test charge should be a small charge, right? Okay, so however small, it will still have ability to create some disturbance in surroundings. Disturbance varakodadanna, you should make the charge value to be very very small. How much small? It should be approaching to 0. Adanala we will see this mathematical expression given in some textbooks. Okay, so on the expression or the meaning anna, so the electric field location is equal to what? Force divided by the and the test charge or the value. Whatever the test charge you are bringing to the location, right? The force acting on the test charge divided by the and the test charge or the value. That's the expression. But we should make this test charge to be very very small. How much small? As small as 0. Adanala we will use this mathematical expression. Another we call it as what? The limit formula. What do you call it as? The limit formula. Okay, va? So this is about the method to find the electric field. Okay, so how do you define electric field? It is defined as the force acting per unit charge at a location. If you bring a charge means the force experienced by the charged particle divided by the and the particle own charge. That is going to give us what? Electric field at the location. Electric field at location is created by whom? On the point or the surrounding charge theriyuma, they are going to create that electric field. Okay, and mathematically if you are looking at an expression, what is it? So limit Q tending to 0 or Q approaching 0, force acting on the charge divided by the charge of that particular particle. That will give us what is the electric field at the location. So if you are bringing the test charge to this location means it will bring in the expression, this expression is going to give electric field at the location. Okay, va? So this is what is the concept of how are we going to measure the electric field experimentally. Now we'll begin with some questions. An electric field of 10 power 5 Newton per Coulomb. Already nama session 5 la paathirkom. What is the SI unit of electric field? Newton per Coulomb. As we go into the discussion, right, we will see that electric field can have some more units also. Okay, electric field 10 power 5 Newton per Coulomb points due west at a certain point. So I might have already told you. So 2D plane la eppadi nama the directions kaamikkiradhu, we will generally take the right side to be what? East, left side as west, up is north, down is south. Appadha nama generally when we look at representation of directions on a 2D plane, that is how we are going to consider. Electric field of 10 power 5 Newton per Coulomb points due west at a certain point. So this is the point. What is the electric field or direction? It is to the west side. What is the value? 10 power 5 Newton per Coulomb. Okay, va? What are the magnitude and direction of force that acts on a charge of plus 2 microcoulomb adukaprom minus 5 microcoulomb? So we have to tell the magnitude and also the direction of forces acting on plus 2 microcoulomb anadi positive charge, and the madri minus 5 microcoulomb anna it's a negative charge. Okay, va? So one by one pola. So first we look at what is the force acting on the positive charge, the 2 microcoulomb charge mela. 2 microcoulomb anani theriyuma? 2 into 10 power minus 6 coulomb. Adana micron anadi 10 power minus 6. So paranga electric field eppadi nama the vector representation kondu varudhu? Because generally right side will take it as what? Plus I, left side is what? Minus I. And the madri up will take it as plus j, down is what? Minus j. Okay, va? Ipo paranga electric field நம்ம எப்படி vector represent பண்றது? It is in the direction of the west, means I cap minus I cap direction இருக்கா? எந்த direction இருக்கா? Minus I cap தானா? So இப்போ பாருங்க electric field as a vector can be given by what? 10 power 5 Newton per Coulomb into minus I cap. 10 power 5 Newton per Coulomb into minus I cap. Okay, va? So now we'll write the force acting on the 2 microcoulomb charge. What is the formula? Q into E bar dana. So Q evla? 2 into 10 power minus 6 coulomb into E another 10 power 5 into minus I cap வரும் ஓகேவா இங்க பாருங்க 10 power minus 6 into 10 power 5 ஆனா 10 power minus 1 remaining இருக்கும் what is it 2 into 10 power minus 1 0.2 தானா so 0.2 coulomb cancel ஆயிடும் 0.2 newton into minus I cap okay so the force acting on that 2 microcoulomb charge the 2 microcoulomb charge மேல what is the force that is there 0.2 newtons force magnitude எவ்வளவு 0.2 newtons தானா direction என்னது minus I cap direction means towards west that is the force acting on the 2 microcoulomb the positive charge so பாருங்க already we discussed it right positive charges experience force in the direction of the electric field okay va other than we have to find what is the force magnitude as well as direction on the minus 5 microcoulomb charge பாருங்க what is the formula here f is equal to q into e bar the same formula q என்னது minus 5 microcoulomb minus 5 into 10 power minus 6 okay va so micro என்னது 10 power minus 6 into e 10 power 5 okay இங்க பாருங்க இதுல அப்படிதான் 10 power minus 6 in 10 power 5 என்னது 10 power minus 1 remaining இருக்கும் coulomb cancel ஆயிடும் okay va so finally பாருங்க the minus cancel பண்ணதுக்கு அப்புறம் what you are going to have 5 into 10 power minus 1 0.5 newton into I cap means the minus 5 microcoulomb அதுக்கு மேல இருக்கிற force என்னது force magnitude எவ்வளவு 0.5 newtons okay va direction I cap என்னது I cap means east so பாருங்க negative charge is experiencing a force in the opposite direction to the electric field positive charge experiences a force in the direction la in the direction of the electric field and negative charge will experience a force in the opposite direction okay va அடுத்த question பாருங்க if a proton deuteron and alpha particle proton என்னது the hydrogen atom right அதுல இருந்து if you remove one electron that is what you call as proton அதுதான் proton okay va deuteron என்ன தெரியுமா hydrogen or isotope deuterium அதுல இருந்து if you remove an electron that is what is called as deuteron so hydrogen H11 இதுக்கு இன்னொரு பேர் என்ன தெரியுமா protium so protium ல இருந்து if you remove electron means you will form proton அந்த மாதிரி deuterium ல இருந்து if you remove electron means it will be what deuteron okay alpha particle என்னது this is the helium 2 plus ion or helium nucleus alpha particle helium 2 plus ion or helium nucleus okay so இப்ப என்ன தெரியுமா these are very common particles even modern physics chapter or even magnetism chapter in the particles பத்தி we will see lot of questions can be found especially in the NEET okay so proton deuteron alpha particle இதுக்கு என்ன தெரியுமா we should understand the relation between them the particles நடுவுல what is the relation between them generally they will consider proton as the reference நம்ம reference எடுக்க போறோம் we'll consider the proton as what reference okay வா இப்ப பாருங்க proton அதுக்கு மேல இருக்கிற charge என்ன because it is having one unit so you will say e deuteron பாருங்க what is the charge of the deuteron 1 unit தானா that is also e alpha particle அதுக்கு மேல what is the charge 2 times positive means 2e so proton ஓட charge என்னது e basic charge neutron e alpha particle 2e okay அப்புறம் we have to talk about the mass so these are the important properties proton so protium right protium is the only atom that will have no neutron inside the nucleus okay so verum it will have what one proton inside the nucleus and electron will be revolving around the nucleus avladha so and the protium la if you remove electron means verum the proton will be remaining part adana there will be only proton so mass will be equal to what mass of proton so mass of that proton will be what the just ore particle irukku adala what is it proton mattum because inside the nucleus there will be no neutron inga parunga deuteron right it is coming from where deuterium la we are removing electron so deuterium enna theriyuma inside the nucleus you will have a proton and neutron வெளியே there will be one electron அதுதான் deuterium ஓட கான்செப்ட் ஓகே நான் இப்ப deuterium ல இருந்து you remove electron அதுதான் deuteron சோ இப்ப பாருங்க deuteron குள்ள என்ன இருக்கும் one proton and one neutron. But என்ன தெரியுமா, the mass of proton and neutron, for a lot of calculations we can take it to be almost same. The proton mass we can take it as approximately equal to what, neutron mass, which means the total mass of neutron will be what, adula oru proton irukka inga neutron, so we can say that the total mass will be 2 times the mass of the proton. ஏன்னா a proton mass and neutron mass will be almost same, adanaala we can say it as what, the mass of the neutron will be what, 2 times the mass of the proton. Okay, so idhula நம்ம கொஞ்சம் டிஸ்கஸ் பண்ணிட்டு இருக்கோம். எது தெரியுமா, because these particles we are going to see in many other problems. So next நம்ம magnetism chapter போகும்போது we will see same, they will ask what is the radius taken by the charged particle and சொல்லிட்டு we will have one standard question. Okay, so when a charged particle is entering into the perpendicular magnetic field, it will take a circular path, and the circular path or radius, that is a very standard question. அங்கேயும் இந்த பார்ட்டிகல்ஸ் நடுவில் we'll have comparison. Even நீங்க அந்த past year need questions பார்த்தா you will get an idea, like they will see that okay, if the proton and neutron are entering into a magnetic field, what will be the radius of the ratio, அந்த மாதிரி questions வரும். So these relations are important, அதனால we are spending some time. இதுக்கப்புறம் I will be just telling that result. Okay, so இங்க பாருங்க alpha particle என்னது, helium 2 plus ion or helium nucleus. helium nucleus குள்ள என்ன இருக்கு தெரியுமா, there will be 2 protons and 2 neutrons. Helium nucleus kulla there will be what, 2 protons and 2 neutrons. Okay, so which means the total mass, because we are saying mass of proton is almost equal to mass of neutron dana, so total mass we can take it as what, 4 times the mass of the proton. So idella namak nabagam vechukonu. What is this, these are the relations between the charge and mass. These are the relations between the charge and the mass. Okay va, so I'll just write them down separately because we got the values. Idhilende we will just write them down separately so that we can use while solving the problem. Okay, so Tanya will write them separately. So alpha, proton, neutron. Okay, so mass 4 times mass of proton, 2 times mass of proton. Charge 2e, okay va, so idella nama use panna porom. If a proton, neutron and alpha particle are kept in the same electric field, so ore electric field kulla we are keeping all these particles, then the options paranga, proton, neutron will have the same acceleration, neutron, alpha particle will have the same acceleration. Idan the alpha particle. Okay va, so neutron, alpha particle will have the same acceleration. Option C anna, alpha particle will have the maximum acceleration, proton will have the minimum acceleration. So they are all talking about the acceleration patti. They are talking about all options, they are talking about the acceleration. So acceleration eppadi varum, because say for example anga irukra electric field oda value E nu vechukonga, the electric field in the location is what, E. Okay va, so force acting on the alpha particle, adu enadhi parunga, charge enadhi 2 times E, right? So 2E into electric field value, adana, that is the force acting on the alpha particle. Okay, so idhilandi we can find what is the acceleration. Acceleration eppadi varum, force divided by mass dana, so force acting on the alpha particle divided by mass of the alpha particle. Okay, so force 2 times small e into capital E. Small e another basic charge, capital E electric field at the location. Okay, mass of alpha particle, what is the mass of alpha particle, 4 times mass of proton. Paranga that or 2 cancel aidum, small e into capital E by 2 times mass of proton. This is the acceleration of the alpha particle. Okay va, adutha paranga we have to find the acceleration of the proton. So force acting on the proton charge another small e dana, so small e into capital E, adilende we will get acceleration enna, force divided by mass. Paranga, what is it, E into capital E by mass of proton. This is the acceleration of the proton. Adukapram we will go to the neutron. So force acting on the neutron, paranga, what is it, charge enna, E is the charge. Okay va, E is the charge. Okay, multiply by the electric field at the location, and that whatever is the electric field at the location. So this is giving us what? Force. Then this is giving us the force. Okay, wow. Now we have to find the acceleration. How do you get the acceleration? The force divided by mass dana. So force is what? E into capital E divided by mass. Mass another 2 times mass of proton. Mass is what? 2 times the mass of the proton. Okay. So what is it that we can say? So which is the correct option? What is the option that we can choose? Paranga. What is the option that we can choose? Alpha particle. Other acceleration in small e into capital E by 2 times mass of proton. And deuteron. Other acceleration in small e into capital E by 2 times mass of proton. So deuteron and alpha particle, right? They will have the same acceleration. Math options. Option is saying proton and deuteron will have the same acceleration. Are they having same acceleration? Proton acceleration is small e into capital E by mass of proton. Deuteron small e into capital E by 2 times mass of proton. So the correct. So option A is not the correct one. Option C paranga, alpha particle will have the maximum acceleration. Alpha particle is not having maximum acceleration. Maximum acceleration proton is having the maximum acceleration. So this is correct. C is also not correct. Option D is saying what? Proton will have the minimum acceleration. Proton is having the maximum acceleration. Okay, wow. So what is the correct answer? Check it, students. What is the correct answer? Option B will be the correct answer. Okay, wow. So what is the one that is correct in this? Option B, deuteron, although the acceleration and alpha particle acceleration will be what? Same. Okay, wow. Other question, other state, other concept. When you look at electric field, right? We can talk about the electric field. So if in a region or space, if the electric field is constant in magnitude and the direction also. Electric field value is what? Constant in magnitude as well as direction. Then we will say the electric field is what? Uniform electric field and so on. We'll call it as what? Uniform electric field. Okay, wow. Say for example, value electric field is given by 2I cap plus 3J cap plus 4K cap Newton per coulomb. I will say electric field is 20 Newton per coulomb towards positive x-axis. This electric field value is all constant value. 2I plus 3J plus 4K constant value. This is change. 20 Newton per coulomb towards positive x-axis. This is change. So everywhere in the space the electric field will be what? Constant. Constant in terms of value as well as direction. Then what do you call it as? We will call the electric field as uniform electric field and so on. Then what do you call it as? Non-uniform electric field. So non-uniform electric field is electric field magnitude might change. An electric field is a vector. The direction might change or both might change. Even if the magnitude change, we'll say it was what? Non-uniform. Direction change means we'll say it is non-uniform. Both are changing also, it will be what? Non-uniform. Because electric field is a vector. So even if the magnitude changes, we'll say electric field is changing. Even if the direction is changing, we'll say electric field is changing. Both of them are changing means then also we'll say what? Electric field is actually changing. Okay, wow. So the concept of uniform and non-uniform electric field. And when we are going into some specific problems, right? They will talk about the uniform and then non-uniform electric field. So if you look at NEET 2020 paper, right? We have a question. Okay. So if in a particular region the electric field is uniform, then the question is what will be the potential difference or something. Okay. So we'll talk about it when we go to the electric potential concept. But uniform electric field in the entire space, right? The electric field magnitude will remain the same and the direction also will be same. அதுக்கு தான் நம்ம யூனிஃபார்ம் எலக்ட்ரிக் ஃபீல்ட்னு சொல்லுவோம். ஓகேவா? Now we said electric field is generated by the charges. So first we talked about how do you measure the electric field, எப்படி இந்த electric field measure பண்றது experimentally. அதுக்கான we use the concept of test charge. அந்த இடத்துக்கு if you bring a test charge, right, the force acting on the test charge divided by the charge oda value, அப்படி பண்ணா we will get what is the electric field at the location. இதானது it's an experimental way. But theoretically எப்படி, how do you find electric field? Because we are saying what electric field is produced by the charges dana. Electric field is produced by the charges. So how are we going to find electric field value that is produced by the charges? இதுக்கு we'll begin with one of the simplest idea, the point charge. Okay, இப்போ பாருங்க, ஒரு point charge capital Q இருக்குன்னு வெச்சுக்கோங்க. We are having a point charge capital Q. Okay, அந்த point charge ல இருந்து let us consider a location at a distance r. Then this is the point charge. Point charge la and mark a point. How much distance? R distance. Okay va? Ipo nama enna panna porom theriyuma? In the distance, in the point la we are going to find what is the electric field. In that what is the electric field? Who is producing the electric field? This point charge is producing the electric field. This point charge capital Q is producing the electric field. Okay va? இதுல என்ன தெரியுமா, we are going to take a approach which is what we have used in the previous scenario. என்னது, இப்போ இங்க electric field E bar னு வெச்சுக்கோங்க, அதோட வேல்யூ நமக்கு தெரியாது. So நம்ம என்ன பண்ண போறோம் தெரியுமா, we are going to bring a test charge to this location. Small q என்னது, test charge. ஒரு test charge அந்த இடத்துக்கு we are bringing it. Now we can tell what is the force acting on the test charge. ஒரு small test charge ஓட வேல்யூ அங்க எடுத்துட்டு வந்தா what will be the force acting on the test charge? And the test charge value Q into அந்த இடத்துல இருக்கிற electric field, what is it? E bar. அந்த E bar தான் நமக்கு தெரியாது, அதை நம்ம find out பண்ண போறோம். So if you are bringing a test charge to that point, the point P ன்னு வெச்சுக்கோங்க. So this is the point P. அந்த point P இடத்துல you bring a test charge to that particular location. அங்க எடுத்துட்டு வந்தா then what will be the force experienced by the test charge based on the field theory formula? என்னது, force is equal to what? Q times E bar. Force is equal to what? Q times E bar. Okay va? அது அப்படியே இருக்கட்டும். Then already in the session 5, last session we have talked about the Coulomb's law oda force expression in vector form. ஞாபகம் இருக்கா? So we talked about the Coulomb's law oda force formula in the vector form. என்னது, so we are trying to find the force acting on the small q charge னு வெச்சுக்கோங்க. அதுக்கு already we have written the formula. என்ன தெரியுமா, force acting on the small q charge due to the capital Q will be equal to what? K into capital Q into small q divided by r square. Distance என்னது, r square into, இப்போ பாருங்க, let us say in the position vector of that location r bar னு சொன்னா then r cap will be the unit vector in the direction. அப்படிதானா? Into r cap. So this is the expression we have studied already in the session 5 la. This is what Coulomb's law in the vector form. So idanadi, we are getting the force acting on the test charge from the Coulomb's law. In the formula angle endu varudhu, from the Coulomb's law. So Coulomb's law la we are getting the force acting on the test charge. But this force and this force expression should be same, right? Rendu onu dana. So force acting on that test charge, one formula is coming from the field theory concept, rendavathu it's coming from the Coulomb's law. Both are the force acting on the test charge dana. So அப்படியே நம்ம அந்த ரெண்டு எக்ஸ்பிரஷன்ஸ் ஈக்குவேட் பண்ணலாம். ஈக்குவேட் பண்ண என்ன வரும் பாருங்க, q into E is equal to what? K capital Q small q by r square into r cap. அவ்வளவுதான், we got it. So small q ரெண்டு பக்கம் நம்ம கேன்சல் பண்ணலாம். கேன்சல் பண்ண என்ன வரும், E bar. கேன்சல் பண்ண வரும், E bar is equal to what? K capital Q divided by r square into r cap. Correct ah நான் வெச்சுக்கோங்க. What is it? K capital Q divided by r square into r cap. Okay va? So now I will erase everything. Simple derivation da. என்ன பண்ணிருக்கோம், we have just got the force on that, on the test charge மேல what is the force. அந்த formula எங்க இருந்து வருது, that formula is coming from the field theory ல இருந்து. Okay, அதுக்கு அப்புறம் we have written the same force formula from the Coulomb's law. ரெண்டு ஈக்குவேட் பண்ண என்ன வரும் E bar ஓட வேல்யூ நமக்கு வந்தது what is the E bar value E bar is what kq by r square into r cap okay so இப்போ நம்ம இந்த டெஸ்ட் சார்ஜ் நம்ம ஃபுல்லா will take off everything ஏன்னா நம்ம டெரைவ் பண்ணிருக்கோம் ஆல்ரெடி we got the derivation என்னது the electric field that is produced by that point charge capital Q என்னது this is the point charge we took right because of the point charge if you mark a location at a distance r and that what is the electric field that is produced by that point charge என்னது k capital Q by r square into r cap இதுல இருந்து என்ன தெரியுமா first நம்ம electric field ஓட magnitude சொல்லலாம் what is the electric field magnitude அப்படியே அந்த மாடுலஸ் எடுக்கணும் so modulus of kq by r square into r cap பாருங்க so இது என்னது k into modulus of q by r square அவ்வளவுதான் ஏன்னா modulus of r cap means what 1 தானா r cap is what unit vector so modulus of r cap என்ன 1 so இதுதான் electric field ஓட magnitude பாருங்க so the electric field that is generated by that point charge at a distance r from it அதோட magnitude என்னது k into modulus of q by r square எதுக்கு நம்ம இந்த modulus எடுக்கிறோம் தெரியுமா because we are talking about the electric field ஓட magnitude so whether the charge is positive ஆகட்டும் or negative we are talking about the magnitude means what it should be a non negative value அதுக்கு தான் நம்ம modulus எடுக்கிறோம் ஓகேவா so this is the electric field that is produced by a point charge at a distance r from it okay அதுக்கப்புறம் we want to talk about the direction part பாருங்க we want to talk about the direction part okay so இந்த ஃபார்முலா நீங்க கேர்ஃபுல்லா அப்சர்வ் பண்ணுங்க இப்போ q case 1 q positive அப்படி எடுத்துக்கோங்க so if q is positive means in the expression நம்ம அப்சர்வ் பண்ண என்ன வரும் k is a positive constant q is also positive divided by r square இருக்கா r square means that will be totally positive இப்போ ஃபுல்லா இந்த kq by r square term என்னது positive means E bar direction will be same as what r cap E bar direction will be same as what r cap means positive charge அதுல இருந்து generate பண்ண electric field right will be எந்த direction இருக்கும் பாருங்க it will be in what direction the direction of the r cap direction of the r cap என்ன தெரியுமா it is away from the charge தானா charge எந்த பக்கம் இருக்கா charge area is on the left side so the electric field at that location in the இடத்துல what is the direction of the electric field away from the charge electric field because of a positive charge will be what away from the charge okay வா இது நம்ம கொஞ்சம் clear-ஆ பார்க்கலாம் like any positive charge you take right the electric field that is generated by the positive charge will be always away from the positive charge okay so அது எப்படி வரும்னு பாத்தீங்கன்னா like say for example we have a positive charge இங்க ஒரு positive charge இருக்க வெச்சுக்கோங்க you want to find electric field here அது எப்படி இருக்கு தெரியுமா it will be away from அந்த direction போகும் electric field you want to find the electric field here அது எப்படி always so you want to find the electric field here na what is it so always you want to find the electric field here means always away from the charge or positive charge la irundhu generate ana electric field it will be always what away from that positive charge okay and the electric field magnitude value enna k into modulus of q by r square of course inga namak modulus thevilla ena the charge is already positive okay va so this is what is the idea of electric field that is generated by the positive charge ingonu case enna iruka electric field that is generated by the negative charge dana because charge and sonna either you will have the positive charge illana negative charge okay so ipo parunga we will go to the case 2 la enna we want to talk about the electric field because of the negative charge okay va so negative charge so case 2 enadi if q is negative inga parunga what is the expression for the electric field k capital Q by r square into r cap idana so q inga irukku vechukonga idha nama electric field measure panna point okay so enadhi r bar in the direction irukra unit vector da r cap okay va so ipo parunga q we are taking negative q negative edutha enna varum q we are taking it as a negative okay ipo parunga k is positive q negative denominator irukka r square is always positive so in the full expression enna varum negative varum which means E bar is equal to some minus number into r cap அதுல நம்ம என்ன சொல்லலாம், E bar will be in opposite direction to the R cap. Opposite direction என்னது, R cap means it is in the particular case R cap எப்படி இருக்கா, it is towards the, so R cap என்னது, இதுதான் R cap direction. Electric field should be in the minus R cap. Minus R cap என்னது தெரியுமா, it will be opposite to the direction of the R cap, which means the electric field that is developed by the negative charge will be what, always pointing towards the negative charge, because of which negative charge the electric field is generated. The electric field will be always pointing towards that negative charge. Okay va, so adu eppadi irukonu solittu we will see it in a particular diagram. Inga paarenga, if you have a negative charge vechukonga, you want to know what is the direction of the electric field at the location. In edathila it will be what, towards the negative charge. Inga namak electric field direction onu vechukonga, it will be what, towards the negative charge. Appadi inga namak electric field direction onu vechukonga, it will be what, towards the negative charge. So electric field because of a negative charge, wherever you take, it will be always what, pointing towards that negative charge. Other magnitude enna, what is the magnitude, k into modulus of q by r square. Inga nama kandipa modulus podanum, ena q is negative. Okay va, so this is the electric field magnitude. Okay, inga nation theriyuma, and the charge positive charge agatum or negative charge, if you go farther and farther, ninga distance la pona enna agum, r is going to increase. The charge location landu you are going to farther and farther, appo enna agum, r oda value will be what, increase. R value will be what, increasing. Appadidana, so r increasing enadhu paarenga, denominator la irukka r square. R increasing means what, but denominator inga increase panna total expression oda value enna agum, it will keep reducing, right? So as r is increasing and the electric field oda magnitude will be what, decreasing. Adha or extreme case enna theriyuma, if you go to infinite distance vechukonga, if you go to, r is becoming so high that it is almost close to infinity, appo denominator enna varum, indha expression la infinity square varum. Infinity square na infinity dana, so any number by infinity enadhi, 0 dana, any number by infinity equals 0. Okay, so if r tends to infinity or approaching infinity, then electric field will be tending towards 0. Means at infinite distance and enna solittu yaru theriyadu, very large distance, at a very large distance which we can't measure, anga electric field oda value enadhi, it will be tending to 0. Okay va, so as r increases, electric field value will be, and the electric field oda magnitude will be what, decreasing. Okay, and the positive charge agatum, the electric field because of a positive charge or electric field because of a negative charge, the electric field magnitude keeps on decreasing. Okay va, inga enna theriyuma, we said as r is increasing, electric field oda magnitude decreases. But if you decrease the r value, what happens, if you are coming closer and closer to the charge, what is going to happen, r value is decreasing means enna paarenga, r value is decreasing. r enga irukku, denominator, nama denominator value decrease panna total expression oda value enna agum, increase agum. So electric field will be increasing, electric field will be increasing. Okay va, adukku or extreme case enna theriyuma, so you are having a charge, or positive charge edukonga, you are having a charge, if you come closer and closer, you will be having the r value approaching 0. In the expression inga paarenga, r 0 substitute panna enna varum, numerator will have some value, divide by 0 panna, anything by 0 is what, infinity. So mathematically enna varudhu, mathematically you are getting e should be approaching infinity, but appadi kadiyadu. Yen theriyuma, any charge is an important theoretical concept, any charge cannot create electric field, any charge cannot create electric field at its own location. Okay, so any charge cannot create electric field at its own location. What if it is creating, or charge adu endha edathila irukko, if it is creating electric field at the same location vechukonga, because what is the statement, it will not create. So if the charge is location means it will create electric field everywhere in the surrounding, but on the charge location enna irukku theriyuma, அந்த இடத்துல it will not create that electric field. Say for example in the counter argument நம்ம prove பண்ணலாம். If the charge is creating electric field at its own location வெச்சுக்கோங்க. So there is a charge, it is creating electric field at its own location. அப்ப என்ன ஆகும்? Because of this electric field there will be a force that is generated தானா? Force ஓட வேல்யூ என்ன? Q into E bar. அப்ப என்ன ஆகும்? It is like that object is able to create a force on itself. Means that object will start moving without any external influence. Idanadi, this is not obeying our Newton's laws, right? Because what is the Newton's law statement saying? An object without the external influence or external force, it will not be able to change its own state, whether it is a state of rest or state of uniform velocity motion. So this is the Newton's first law concept, right? Newton's first law enna nam padichirukom. We talked about the law of inertia. So an object which is at rest will continue to be in the state of rest. And madri an object which is in uniform velocity motion, it will continue to be in the uniform velocity motion. Inga enna iruka? The charge is able to create electric field at its own location. Then theoretically, if it is happening, so then this is a scenario. It really agadu. It is not going to happen like this. If it is able to create electric field at its own location vechukonga. Adanala what is the outcome going to be? The outcome is going to be that the charge will be able to create a force on its own self and it will be able to start changing its state. Okay, which means what? We are disobeying the Newton's laws. So if this scenario is really happening, means what is it going to do? It is going to disobey the fundamental laws of motion. Okay, it's going to disobey the fundamental laws of motion. Otherwise this situation cannot be happening. Means what? The charge, if you keep a charge at a location, it will create electric field everywhere, even up to infinity distance. But of course anga enna agum? The electric field or the strength will become so small that it will be almost close to zero. But it will not be able to exert electric field at its own location. Okay, so in infinity adayadu, it will be what? At its own location, the electric field value will be what? It will be equal to 0. At the location of the charge itself, right? Electric field value number, it will be what? 0. Okay, wow. So sometimes we can have some theoretical questions based on this. So all these are a little bit important for the theoretical questions and things like that. Okay, wow. Now diagrammatically eppadi theriyuma? We can look at it like this. Ipo idu oru positive charge nu vechukonga. The positive charge oda idilundu, if you are looking at what is the electric field that is developed by that positive charge, eppadi adu represent pandrathu namma? So if you are looking at this location, what will be the direction of the electric field? Ippadi dana? It will be away from the, at this location away, at this location away, at this location you want to represent the electric field, means away from the charge, inge away from the charge. So parunga enna varudhu? You are able to represent the electric fields by using the lines. Lines are representing what? These lines are representing what? They are representing, they are representing the direction of that electric field. The lines are representing what? Direction of the electric field. Okay, wow. We are going to discuss about it one more time. So these lines are going to be called as electric field lines, and the concept, but we will talk about it later. But we just look at the idea of how we can diagrammatically represent. We have a negative charge field, because a negative charge will be always towards the charge dana. So at this location means we have to represent towards, and at this location means towards. So the electric field will be what? Always towards that particular charge. It will be always towards that negative charge. Okay, wow. So we are able to represent the electric field with the help of these lines. So what are we going to call these lines as? We are going to be calling them as what? Electric field lines. We will talk about it later. Okay, but this is how we can diagrammatically visualize how the electric field produced by that positive charge in that surrounding will exist, and how the electric field that is produced by the negative charge will exist in the surrounding. Okay, va? So this is the concept of the electric field. One point another ima, the positive charge or negative charge, in taniya cases, these are not together. இந்த பக்கம் ஒரு பாசிட்டிவ் சார்ஜ், இந்த பக்கம் நெகட்டிவ் சார்ஜ், அப்படி கிடையாது. these are all two separate cases. ஓகே, ஐ அம் சேயிங் ஒரு இடத்துல வெறும் பாசிட்டிவ் சார்ஜ் மட்டும் இருந்து வச்சுக்கோங்க, அப்படி இருக்கும் எலக்ட்ரிக் ஃபீல்டோட கான்செப்ட். ஒரு இடத்துல if you are having only negative charge, the electric field generated by the negative charge will be like this, இந்த பேட்டர்ன்ல இருக்கும். ஓகேவா? now electric field will exist irrespective of presence of other charges. இது என்ன தெரியுமா? it is not like okay, நம்ம அந்த இடத்துக்கு ஏதாவது இங்க டெஸ்ட் சார்ஜ் எடுத்துட்டு வந்ததா we will be able to see the presence of the electric field. அப்படி கிடையாது. the electric field is going to exist. so if there is a negative charge, the negative charge is going to create the electric field in the entire region around itself. அது அப்படியே இருக்கும். whether there is any other charge in the surrounding or not, the electric field is generated by that negative charge will be as it is. என்ன ஆகும்? if you bring some other charge into surrounding means the charge that you're bringing, right, that will start experiencing force. அவ்வளவுதான். the charge that you're bringing, இப்போ நம்ம இந்த இடத்துக்கு we are bringing a test charge னு வெச்சுக்கோங்க. test charge will interact with the electric field. whatever the electric field existing there, it will interact with the electric field. interaction என்ன வரும்? the test charge will start experiencing the force. but the electric field as such will exist irrespective of whether there are other charges in the surrounding or not. okay va? so this is the concept of the electric field due to the positive charge. okay, now if you are having many charges, so இப்போ பாருங்க, இங்க ஒரு பாசிட்டிவ் சார்ஜ் இருக்குன்னு வெச்சுக்கோங்க q1, இங்க ஒரு நெகட்டிவ் சார்ஜ் q2, இங்க ஒரு பாசிட்டிவ் சார்ஜ் q3, இங்க ஒரு நெகட்டிவ் சார்ஜ் q4, நிறைய சார்ஜஸ் சரௌண்டிங் இருக்குன்னு வெச்சுக்கோங்க. I want to know what is the electric field at the location. இந்த இடத்துல I want to know what is the electric field. இப்போ பாருங்க, the q1 will generate electric field. அது எப்படி இருக்கும்? it will be away from q1. அதோட வேல்யூ e1 எடுத்துக்கலாம். q4 will generate electric field. இப்போ பாருங்க, it's a negative charge தானா? so electric field because of q4 will be what? it will be towards that charge. அந்த மாதிரி இங்க பாருங்க, there is a negative charge q2. so electric field because the negative charge will be what? towards that negative charge. இங்க என்ன இருக்கா? there is a positive charge. so electric field because of positive charge will be what? away from the positive charge. பாருங்க, at location, if the location is surrounded by many charges, அப்படி இருந்தா என்ன ஆகும்? each of the charges will generate the electric field தனித்தனியா. we want to know what is the total electric field means same. நம்ம அந்த forceல என்ன பண்ணிருக்கோம்? cumulative force னு சொல்லிட்டது தானா? so you want to know the overall electric field or the net electric field at the location. அது எப்படி வரும்? we have to simply add all the electric fields vectorially. எப்படி ஆட் பண்ணனும்? we have to add all the electric fields what? vectorially. அதுல இருந்த cumulative electric field வரும். what is it? this is what we call as the cumulative electric field னு சொல்லலாம், or we can say resultant electric field or net electric field. okay, so we can use different names for that. okay va? so if there are many charges in the surrounding, then each of the charges will develop electric field. now total electric field வேணும்னா what you have to do? we have to take that addition of all the electric fields generated. addition is சொன்னது, it's not like simply we are adding like 10 plus 2 அப்படி கிடையாது. we have to add them vectorially by following the vector principles. okay va? so this is the idea of cumulative electric field when there are many charges producing the electric field. now this is another important concept for the problems. even in fact in past year NEET also we got one question. and தெரியுமா? the idea of null point. null point particularly along the line of two charges. null point particularly along the line of two charges. first நமக்கு null point என்னன்னு தெரியும். null point என்ன தெரியுமா? if the electric field at a location, if the electric field at a location is 0, அது நம்ம என்ன சொல்லுவோம்? null point னு சொல்லுவோம். ஓகேவா? so if the electric field at location is 0 means we'll say it as what? null point. அந்த மாதிரி magnetismலயும் we are going to talk about the null point. அங்க என்ன தெரியுமா? if the magnetic field at a location is 0, we'll say it as what? null point in the magnetic field. so if at a location in space electric field is 0, magnetic field is 0, and the மாதிரி gravitational field is 0, then you know what you call it as? that particular point in space we will call it as absolute null point and so. so if a location in space and the இடத்துல electric field is 0 means if you put a charge means the charge will not respond. ஏன்னா சார்ஜ்க்கு மேல ஃபோர்ஸ் இருக்காது. Because only when there is electric field, if you put a charge there means that charge will experience a force. அதுல இருந்து you can see the movement. அந்த மாதிரி if the magnetic field is zero means what? The magnets also, if you are keeping there means they will not respond, or magnetic particles they will not respond. If the gravitational field is zero means what? If you keep a mass means generally if there is a gravitational field and energy, the mass will start experiencing a force. Gravitational field zero means what? And even if you keep a mass means it will not experience any force. So that is the reason why if all the three fields are zero, we will call it as absolute null point. Okay va? But in we are discussing only about the electric field or null point. So null point particularly along the line of two charges. Line of two charges and if we are having two charged particles q1 and q2. Okay, so the line on which the charges are present, the line of the two charges. Okay va? So this is an important concept especially for the numericals. Idhula we have actually two cases. One enna theriyuma, if the two charges are like charges. Anyway, the two charges are what? Like charges. Inga parunga, I will explain this with an scenario. So idu nama line a edukalam. This is the straight line. Okay va? Idhula you keep one first charge q1. Idanadi like charges dana means let us take them as what? Rendu charges nama positive ah edukalam. So this is what? q2. Idhum positive da. Okay, now the line is there, right? The line that is having these two charges will divide the line into three segments. இங்க பாருங்க, என்ன தெரியுமா? இந்த பக்கம் இருக்கிற பார்ட் என்னது? A segment னு சொல்லலாம். இது என்னது? நடுவுல இருக்கிறது B, அந்த பக்கம் இருக்கிறது C. Okay, so இப்ப carefully observe பண்ணுங்க. If you take a point in the region B, and the region B ல you take a point, ஏதாவது ஒரு பாயிண்ட் எடுங்க. Field because of q1 will be what? அப்படி இருக்கும். Field because of q1 will be what? ஏன்னா because positive charge will develop a field which is away from the charge. அப்படிதானா? அந்த மாதிரி we look at field at the same location due to that q2 positive தானா? So q2 will result in an electric field which is away. So பாருங்க, if you mark a point which is in this region B, அதுல என்ன இருக்கா? Both the electric fields, the electric field E1 which is generated by the q1 charge and E2 which is generated by the q2 are in opposite direction. Okay, அதனால என்ன ஆகலாம்? If two vectors are in opposite direction, then if their magnitude is matching, for example இந்த பக்கம் ஒரு electric field value of 2 Newton per coulomb வெச்சுக்கோங்க, அந்த directionல 2 Newton per coulomb. When you say you want to add both of them, then what will be the total electric field? நீங்க add பண்ண என்ன வரும்? It will not be happening all places. The addition will be zero when if and the E1 oda modulus and E2 oda modulus, right, are same. Enga? In the region B. So if you are having two charges which are like charges, அப்போ null point எங்க வரதுக்கு சான்ஸ் இருக்கும்? Null point can come in between that two charges. In the region B and சொல்லுவோம் தெரியுமா? This is the region. In the region வரதுக்கு there will be a chance. Okay, how do you find out the exact location? We will look at a problem. But எங்க வரும்? The null point is going to come in the region between the two charges. Okay va? So எப்படி நாம இத conclude பண்றது? When you look at a point in the region between the two charges, both these electric fields, and the electric field generated by the q1 charge and the மாதிரி electric field generated by the q2 charge, both are in the opposite directions. அதனால there is a chance for them to cancel. எப்போ cancel ஆகும்? When their magnitudes are equal. Okay va? So this is where we will have the null point. So null point எங்க வரும்? Null point will be happening in the region between the two charges. Okay, that is what we are calling as the region B. Okay va? Now you will also have a doubt. Sir, what about in the region A and region C? Because நம்ம B பத்தி டிஸ்கஸ் பண்ணிருக்கோம். But what about the region A and region C? அதை நம்ம பார்க்கணும். So பாருங்க, region A ல நீங்க ஒரு பாயிண்ட் எடுத்து பாருங்க. At this location, field because of q1 is what? Positive. Field because of q1 will be away from q1. அப்படிதானா, it will be away, அந்த பக்கம் இருக்கும். At this location field because of q2 positive charge தானா, so field at the location will be away. இங்க பாருங்க, the E1 and E2 are what, they are in the same direction, means what, they will be adding to each other, they are not going to cancel, they will be what, adding to each other. Okay, அந்த மாதிரி இந்த பக்கம் பாருங்க, if you mark a point in the region C, in the region C ல mark பண்ணா at this location, right, field because of q1 will be what, away from q1, ஏன்னா q1 is positive, q1 is positive. Okay வா. What about the field because of q2 positive தானா, so இங்க என்ன இருக்கா, both the fields are in same direction, means they will be adding. புரியுதா? So the charges are like charges, then the possibility of the null point will be in the region B. Region B another, that is the region in between the two charges, okay. So if you will have one more doubt, என்ன தெரியுமா, sir நம்ம இந்த problem we have solved by taking the two charges as positive, but what if they are negative, அதுலயும் same situation we are going to get. If the charges are negative, அதுலயும் we are going to get the same situation. பாருங்க, if this is q1, இங்க என்னது நெகட்டிவ் ஆயிடுக்கலாம், இது என்னது q2. ஓகே, இப்போ ஸ்ட்ரைட்டா நான் ரீஜன் B பத்தி தான் நம்ம டிஸ்கஸ் பண்ண போறது. ஓகே, ரீஜன் B ல நீங்க ஒரு பாயிண்ட் எடுங்க. ஓகே, so now electric field because of q1 என்னது நெகட்டிவ் சார்ஜ் தானா, electric field because of q1 will be what, it will be towards q1, ஏன்னா q1 is a negative charge now. Okay, அந்த மாதிரி electric field because of q2 will be what, towards q2. இங்க பாருங்க, both the electric fields are again in opposite direction, so there is a possibility that the E1 and E2 we can also say nullify each other ன்னு சொல்லலாம். cancel இங்க ஒரு word என்ன, nullify each other ன்னு சொல்லலாம். ஓகேவா, அது எப்போ ஆகும், when அந்த E1 ஓட modulus and E2 ஓட modulus when their magnitudes are same. எப்போ இந்த possibility வரும், எங்க null point வருது, null point is going to come at a location where we know both the electric fields are in opposite direction, but exactly when they will cancel, when the magnitudes are equal. Okay va, so this is the null point concept. Okay, so this is when the two charges are like charges. Okay, the next class enna theriyuma, we'll start with the other scenario when we have two charges which are unlike charges, means one is a positive, rendavathu negative. We'll see where we are going to get the null point in this particular situation. So unlike charges irundha, where we are going to get the null point. Yen nama idukku mela we are spending some time anna, because this is a very important model of question. Okay, so we'll possibly get numericals varala idilundu, like they can ask exactly where is the null point, and the madiri question varala illana, we can even have some theoretical questions. Okay, so in the region there can be a possibility for the null point, and the madiri theoretical questions varala. Okay va, so try and solve some questions on whatever we have practiced in today. Okay, so we'll see in the next session.